All right, so this is the first of a couple lessons just focused on working more with radicals, but it's also the last lesson before we return to the textbook. And so if I look at these expressions, I want to simplify each of these. Right now there's no variables in these. And so one thing to realize here is that if I gave you 2x plus 6x, we call those like terms, and you can say they equal 8x. Well, I have 2 root 5 and 6 root 5. And so the root 5 is the same radical, so we call these like radicals. And that phrase is really no different than like terms, which means we can put these together just like terms. And so I can just go 2 plus 6 equals 8 root 5. A common mistake is we go, well, root 5 plus root 5 is root 10. And that is wrong, but I'm going to write it down. So it's not the same as 8 root 10. Again, quite simply, we have 2 of these root 5s over here. We have 6 more of these root 5s. Put it all together, we have 8 of these root 5s. But the radical shouldn't change. But it is a pretty common mistake, so I do recommend writing down what I put in red there. That's it. Like I said, really no different than like 2x plus 6x. And so over here, this is really no different than like x minus 4x. X minus 4x is negative 3x, because it's like a negative 1. Sorry, it's like a positive 1 in front of there. And so in this case, instead of x, I have root 8. And I can, if I want, put a little imaginal 1 there, and I have 1 take away 4. So negative 3 root 8. That's it. Again, pretty straightforward idea because we've been working with like terms for so many years now. Like radical, as long as it's the same radical, you can put them together just like the like terms. But what if we don't have the same radical? And so I think these are the last 2 examples from the lesson. Yep. So if I focus on this one, I can't just put these together. In fact, if I just say root 50 and root 2 is root 52, that's completely wrong. So if they're both root 50 or both root 2 or both the same root, I could find a way to put them together. But they're not. So right now, there's nothing I can do. Right now, there's nothing I can do to simplify this if I leave it in this form. But I don't have to leave it exactly in this form. What do I mean? That root 50, I can write as a mixed radical. And that's because I know that 50 is not a perfect square, but I know that 25 is, and 25 times 2 is 50. So I'm going to take root 50, and I'm going to rewrite it as root 25 times root 2. And root 25 is exactly 5 whole. So I have 5 root 2 plus 3 root 2. And now I have my like radicals. Now I have 5 root 2 plus 3 root 2, which makes 8 of these root 2's. And again, everything you see here is equivalent, but it's hard to argue that this here is not considerably simpler looking than what I gave you. But they're equivalent. I don't need a calculator to know they're the same. Although if you went to a calculator and typed in the square root of 50 plus the square root of 2, you get some messy decimal, and you get the exact same thing if you just did 8 times the square root of 2. All right, so with that said, this is the last example. There's a number of things to look at, but again, right now there are no like radicals, but we can try to find some like radicals. And we do that by first taking our radicals and seeing if we can write them as mixed numbers or mixed radicals. And so root 27 is not a perfect square. It's a perfect cube, but not a perfect square. But it is the same as 9 times 3, and 9 is a perfect square. So I'm going to rewrite root 27 as root 9 times root 3, or just 3 root 3. Keep in mind, there's a negative in front of this. OK, next, 3 root 5. 5 is a prime number. There's nothing more I can do to that, so I'm just going to copy that down. Plus 3 root 5. Root 80. So 80 is not a perfect square, but what multiplies into 80? Well, a number of things. 5 times 8. Well, no, not 5 times 8. Sorry, 4 times, 8 times 10. But again, that's not helpful. What is, for example, 4 times 20 is helpful. Or 16 times 5. That's it. I don't expect usually people to jump to 16 times 5 when it comes to what multiplies to 80. So I'll do this in a few steps. But root 80, I can definitely break up. And I'm going to break it up first into root 4 times root 20, which is 2 root 20. However, again, 20 I can continue to break up. And so I can break up 20 into root 4 and root 5. So 2 times 2 times the square root of 5. Everything you see highlighted in green is equivalent, which means the square root of 80 is the same as just 4 times the square root of 5. Well, that was a lot of steps, and it would have been a lot faster if I immediately went root 16 times root 5 and would have got 4 root 5. That said, I didn't do that because that's not usually what people do right away. Just because usually we don't think about our 16 times tables or something like that. But now, everything you see in green is equivalent. And so root 80 is the same as 4 root 5. So all that's left now is this 2 root 12, just the root 12 part. Root 12 is the same as root 4 times root 3, so 2 root 3. That's it. I got a minus 2 in the front of that, minus 2 times all that. So really, what do I have left here? It's getting pretty messy. Let me all kind of write it nice and neatly down here. I have minus 3 root 3 plus 3 root 5 minus 4 root 5 minus 4 root 3. Because again, up here I had 2 times root 3. And so maybe I'll put my little color coding back in. But now, after all this work, I can see what the like terms I have. For example, these two are like terms, and these two are like terms. So I can put those together. So I'll do the root 3's first. Minus root 3 minus 4 root 3 is minus 7 root 3. And 3 root 5 minus 4 root 5 is minus 1 root 5. I don't really need that 1, so I'm going to erase it. Well, I need the square root, though. And again, I'll just kind of show you where these came from by underlining them. And so, before I finish this, if I zoom out and show you this one question, yeah, there's a lot of little steps. Things are picking up a bit. And none of the individual steps are difficult, but there are a lot of little steps now, and it's easy to lose track, which is why we want to be really careful as we kind of follow along through our work. But again, while that has a fair amount of steps, don't forget, if I go back to the beginning, these did not, right? So yeah, that one question there had a fair amount. But that's where we're going to stop. So the remaining lessons in this unit will start to focus directly on work from the textbook. But this is the last lesson before that.